In this video, we are looking at the questions in the Chapter 5, Section 6 slides. And we're first starting out by asking which of these problems are expressed in scientific notation. So this first one is in scientific notation because this number here is between 1 and 10, and this is 10 to some power. So yes, this is in scientific notation. This one is not in scientific notation because this 0.2 is not between 1 and 10. This one is not in scientific notation because we don't have 10 to a power, we have 5 to a power. This is in scientific notation, but it's kind of an unnecessary scientific notation because this is just 10 to the 0, so that's 2.7 times 1. Here we have 34 times 10 to the 4th. That's not between 0 and between 1 and 10, so that's not scientific notation. 8 times 10 to the negative 6. Usually we'd write it as 8.0 times 10 to the negative 6, but this is still in scientific notation. Here we are not, this is negative 2.8 divided by 10 to the 3rd. That's not in scientific notation because it's divided, not multiplied. In this problem, set of problems, we're asked to change these numbers in scientific notation to their ordinary equivalents. So this is 3.6 times 10 to the 4th. I need to move my decimal place 4 to the right. So that's going to be 3.6000, 36,000. Here I've got a negative 2, so I need to move my decimal point 2 to the left. 0.028, 28 thousandths. This is 10 to the 0, that's the same as 1, so this is just 1.1. Negative 6.9 times 10 to the negative 5th. Okay, so we're going to leave our negative up front, and we're going to move our decimal place 5 places to the left. So I'm going to get 0.0000069. 69 millionths. Finally, we need to take our, we've got times 10 to the 6th, so we move our decimal place 6 to the right. That's negative 9, negative 9,700,000. Here we're asked to express these numbers in scientific notation. So we start by writing this number as 2.85, and then we figure out, well, we've moved our decimal point 2 to the left, so we're going to need to multiply this by 10 squared. Here, we've got a 7 at the end, so that's 7.0 times, we've moved our decimal place 3 to the right, so we need to have this 10 to the negative 3. 91, that's 9.1 times 10 to the first power. 85,000 is 8.5 times 10 to the fourth power. And finally, we've got 74 thousandths. We're going to move our decimal place 4 to the right. This is 7.4 times 10 to the negative 4th. Here we want to express these numbers in scientific notation. Well, we've got 37 times 10 to the 5th is 3.7 times 10 to the 4th. 0.03 times 10 cubed is 3.0 times 10 to the, okay, so that would be, this is 10 cubed, then that would be, let's just turn it into a regular number first. We'll need to move our decimal place 3 to the right, so that's going to be 30, which is 3.0 times 10 to the first. Now we want to multiply and express the product in scientific notation. So when we do this, first we multiply our numbers, and then we multiply our powers of 10. 4 times 2 is 8, times 10 squared times 10 cubed is 10 to the fifth. 3.7 times 2.5, I don't particularly want to do that by hand, is 9.25 times 10 cubed times 10 to the first is 10, negative first is 10 squared. 8.4 times 5.2 is 43.68. We're going to need to move that one decimal place to the left after we've written this out. 43.68 times 10 to the negative 2 plus negative 3 is negative 5. Well, we have to move this one decimal place to the left. That's 4.368 times 10 to the negative 4. Divide and express the quotient in scientific notation. Okay, so again, we just divide the numeric part and then deal with our powers of 10. 3 divided by 2 is 1.5 times 10 to the 5 minus 2 is 3. 9.6 divided by 3.2 is 3 times 10 to the negative 111 minus 29 is 82. 1.44 divided by 6 is 0.24, so we're going to have to move the decimal place after we're done. Negative 3 minus negative 5 is positive 2 times 10 squared. Okay, so now we need to move this over 1, 2.4 times 10 cubed. I want to double check that one. I'll write this as in standard form. 0.00144 divided by 6 to the negative fifth is 0.00006. That should actually be 24. So this is only 10 squared. No, I had one fewer 6 than I needed. This should actually be 10 to the first power, not 10 squared. 1.25 times 10 cubed. Okay, I can divide this by 5 and get 0.25 times 10 cubed. Move my decimal place to the right to get 2.5 times 10 squared. A star is 4.2 light years from Earth. If 1 light year is 5.87 times 10 to the 12th miles, how many miles from Earth is the star? Well, we're going to take this 5.87 times 4.2. To get 5.87 times 4.2. There we go, that's better. 24.654. And that's times 10 to the 12th, but we need to move this decimal place 1 to the left, which is going to make it 2.4654 times 10 to the 13th miles. An angstrom is 1 times 10 to the negative 7th millimeters. What is the length in millimeters of 14.2 angstroms? lost something. Find it later. There it is. Okay, and angstrom is 10 to the negative 7th millimeters. What is the length in millimeters of 14.82 angstroms? Well, that's going to be 14.82 times 10 to the negative 7th, but we need to move this decimal place over here. So that's going to be 1.482 times 10 to the negative 6th. I apologize for the whining dog. 1 coulomb is approximately 6.28 times 10 to the 18th electrons. So how many coulombs do 2.512 times 10 to the 21st electrons represent? So for this, we'll take 2.512 times 10 to the 21st, divide it by 6.28 times 10 to the 18th. Okay, well, 2.512 divided by 6.28 is 0.4 times 10 to the 21 minus 18 is 3, but we're going to have to move this to the right one. So that's going to be 4 times 10 squared, or 400 coulombs. Finally, we're asked to raise these to the indicated powers. 2 times 10 cubed quantity squared is going to be 2 times 2 squared is 4 times 10 cubed is 10 to the 10 cubed squared is 10 to the 6th. 4.2 times 10 to the negative 4th cubed. Okay, 4.2 cubed is, just double checking, 74.008 times 10 to the negative 12. But now we need to move this 1 to the left, so that's going to subtract 1 here. That's 7.4008, 088, that should be, times 10 to the negative 11th. Finally, we've got 7.3 times 10 to the negative 2 raised to the negative 5th power. So, stop it, Lonnie. Stop. So we're going to do this way. We'll take 7.3 and raise that to the negative 5. And we get this ridiculous number, 0.0000482376, and we'll leave it there. It goes on from there, but we're just going to go that far. Times 10 to the 10th. Well, that just means that we can take this decimal place and move it all the way over there, but we don't want to move it all the way over there. We want to move it here. Keep it in scientific notation. That's going to be 4.82376 times 10 to the 5th. That's it for this video. If you have any questions, please get in touch.